The modern construction now in Norway is getting the balance right between heat retention and mitigating moisture from the inside envelope of the building. One of the most crucial aspects of the external envelope is to maintain a ratio of impermeability of 1 to 10 from the inner vapor barrier to the wind-loaded sheeting that we can actually see behind me here. That ratio of 1 to 10 must be maintained to ensure that we don't actually get moisture problems building up within the fabric of the building itself. So, Knut, we've got here the wind barrier, cross-battened.
Yes.
And what is this detail? What's going on here?
Well, these are the bottom boards with some distance in between. When the top board comes on here, you get an opening here, which provides ventilation from the bottom of the wall to the top. And it also provides drainage, because if you have the other boards on here, you'll get some water coming in if you have driving rain, and it has to be drained down. That's a very important part of the outside cladding, especially in the parts of Norway where you have a lot of driving rain.
Right. And this detail here, why have we put that in position?
That is to prevent rodent from coming in behind the cladding.
Right. Yeah. So we've got the outer barrier, we've then got the wind barrier,
Yes.
and we then have the formed cavity.
Yes, you have the whole frame, which you fill with mineral wool, and then you come to the inside with the vapor barrier and the internal lining. That's the whole lot.
And that's where this ratio of 1 to 10 must
Yes,
be maintained.
yes. So this should be 10 times more open to vapor diffusion than the inside vapor barrier.
And if that ratio is out of balance, what's going to happen to the building?
What we usually get then is condensation on the inside of the wind barrier, which of course can lead to fungus and also eventually poor indoor climate. The details we have been talking about here are maybe more important now than before, because in the past, when you heated the house to the same extent as you do today, the external parts of the wall had a higher temperature and they dried out more rapidly than what they do now.
The buildings are still going to be quite cool, are they, in the summer, when the summer comes?
That's not a big problem so far, but I think with the very low energy houses, that could be a problem. So that means maybe now we don't have a very warm climate in Norway, but sometimes we have very hot summer days, and maybe you should open the windows and let the wind pass through.
So here we are during the construction phase, and I noticed that no vapor barrier has yet been put up, yet the operatives are working in here producing, they've got the heat on, they're producing
Yes.
moisture, and I think that there's a problem.
Yes, it's a problem, and it also demonstrates the importance of having a moisture barrier, because in this situation water vapor will pass through the insulation material, and you get a situation like this where it's completely wet on the backside of the insulation material, and you have ice which has formed on the inside of the wind barrier.
The outside temperature is -8 currently,
Yes.
and we've probably got an internal temperature somewhere around 20 degrees
Yes.
with heat going on, and of course this is the result.
So the thing is to get the vapor barrier fixed as quickly as possible.
So here we can see the vapor barrier is now being put in place. What's the main methods of sealing around these apertures?
Along the window, the method is that you use the trim around the window to press the polythene sheet to the window frame, so that you don't have any leakages here. And you can also see that we insulate the gap between the window and the frame. The other critical detail is usually along the roof, where the polythene sheet should be continuous, so that you don't have any air leakages from the inside and into the wall.
We're up here on the top floor, so we've got a sloping soffit here, and I noticed that there are no areas where there's any lighting in the ceiling at all below the loft void. Why is that?
Well, that's the same thing as we've been talking about, that you should have no openings in the internal vapor barrier. If you have a downlight or even you have electric wiring in the roof, it's very easy that you get leakages, and the vapor pressure is higher up near the roof than it is further down in the construction. So it's more critical in the roof than it is for the walls.
And presumably as well, the downlighter or the luminaire would also be a vehicle for heat loss, because it's a much thinner or less resistant material.
Definitely, and also of course the thermal insulation would be reduced on top of the downlights. So there are several reasons why you should try not to have this type of insulation in the roof.
So in essence, really, in summary, the critical point on timber frame construction is making sure that it is airtight, hermetically sealed, and the vapor barrier is continuous and well lapped to prevent any moisture migration through it. One punch a hole and
it could be
and
a
it's
problem.
lost.
That is on one condition, and that's a very important condition, and that is that you have proper ventilation of the house. Otherwise you would have a problem.
So here we've got the plumbing pipes, the plastic plumbing pipes, which are running through these convoluted plastic conduit pipes. And what's the advantage of a system like this?
Well, you have the mains coming in here, and the water is distributed through the PEX pipes here to the different taps. And if you have a leakage in this system, if you go upstream, the water will run down through these outer pipes and into the cabinet and drain out onto the bathroom floor. If you have a leakage in the other end, it will go down here and it will come out next to the tap and onto the floor again.
So that's marvellous, because it means that we know that plumbing pipes at some stage in their life are going to leak. And what this system does is to actually manage that leak and channel it and focus it into an area which is already a wet room anyway, here, the bathroom. And in other cases, actually directing the water back through the conduit out alongside the pipe. So it doesn't have to obviously cause widespread damage to a timber frame building.
That's the whole idea, because a leakage could be disastrous in a timber house.
Now, the forms of heating, the most popular choices here in Norway is either electric panel radiators, but increasingly now we're wanting to move people towards actually having a wet-filled system actually in the floor. Why is that?
Well, it's mostly the authorities that are encouraging this, because then you can use different sources of energy. The idea is that electricity is valuable for other purposes than heating. That means that you could use electricity even in the waterborne system. You could use oil, but you could also use wood or pellets. You could use a heat pump, whatever you could think of as alternatives.
So again, it's addressing the whole sustainability question through the whole construction process, using sustainable materials and obviously renewable energy sources.
That's the idea, because even in Norway, electricity is becoming valuable.
So we've got an inbuilt vacuum system.
Yeah.
Every home should have one, of course. And I understand that when the hose is actually connected, a signal is sent to start the central vacuum unit off. But there's actually quite a serious point to be made as to why Norwegian homes now are having inbuilt vacuums like this.
Well, I think there are mainly two reasons. One is that it makes work easier. The other one, which I think is more important really, is that you bring all the dust into one container where it's collected. You don't send the fine dust through the ordinary vacuum cleaner and back into the air again. So that's maybe the most important thing.
And of course, you know, fine dust in a dry atmosphere here as well is obviously going to, you know, to impact on the on the microclimate inside the envelope. So it's managing the moisture and also managing the dust population, and presumably also helping to some degree to actually reduce or mitigate the house dust mite population.
Yes, I think that's correct. And we also know from investigations has been done in Norway that in places, schools for instance, where they use a vacuum cleaner often, the pupils have more problems than if you leave the vacuum cleaner alone for longer periods, which is to demonstrate that the fine dust is a problem for quite a few people.
Another favoured aspect of construction on timber frame buildings is actually building off of a solid floor slab as opposed to a timber suspended floor. Now in the UK I tend to advocate more having a timber suspended floor because climatically we can cope with it, but here the climate is very much different. And the problems that have been encountered is that dew point, even during the summer months, is regularly achieved in the crawl space, in the subfloor void. So the floors, the timber suspended floors, were simply rotting from below the floor all the way through. So the decision now has been taken to actually construct the timber frame buildings off of a purpose-made floor slab, solid floor slab, which will incorporate up to 30 centimetres of insulation below the floor slab. No longer would they rely on the protection from the ground because heating systems are now being loaded into the floor slab, water-borne systems, and having the 30 centimetres of insulation will actually mitigate and prevent heat loss going into the ground. So the gain is inside the building. The current insulation standards for walling here in Norway is 25 to 30 centimetres for walls, and a similar level now up to 35 centimetres for roofs. So they really are hermetically sealing the building and holding the heat in. And of course windows now, by improving the thermal resivity of windows, they could ease back slightly on the thermal insulation standards for the walling. Of course, you can go to the optimum standard by having the maximum standard to the walling and of course the maximum standard to the windows. And by doing that, you would then force the heat further through the roof of the building. So the insulation standards are increasing to encapsulate that heat. There is also the matter of mitigating the moisture that builds up within the inside envelope from normal use and occupation. And the current standard here in Norway is achieving 0.5 air change, which is a total air change of the entire cube of air inside the dwelling every 2 hours. And this is being achieved by heat recovery. So the water vapor laden air is being taken out of the envelope, reheated to about 20 degrees Celsius and inputted back into the building. And this is the preferred option from the old system of actually having a passive stack system where the air would be forced up a chimney by inducting air through trickle vents in the windows, and in some cases actually using a mechanical extraction device. So heat recovery for the Norwegians is the way forward to mitigate and find this balance between holding on to the heat for longer and mitigating the moisture out of the building.